Lithium is one of the first elements on the periodic table, atomic number 3, and represented by the symbol Li. It's increasingly lightweight and low density. This stuff is highly reactive and flammable too, showing that it's something of an element of extremes. As such, to keep it pure and to avoid reactions with the air around it, lithium has to be kept in inert liquids or vacuum chambers. Next, lithium is known for its unstable nucleus, with the only stable isotopes of it being lithium-6 and lithium-7, and even they are only just making the cut for the stable criteria. Nevertheless, it's this which makes lithium a perhaps surprisingly rare element in our solar system compared to the others near it on the periodic table. While hydrogen and helium are everywhere, lithium not so much. The name lithium is derived from the Greek word lithos, meaning stone. It's found in rocks and minerals. It's also a toxic metal, however, even though traces of it are all across the animal kingdom and found in many different plants and creatures around the world. A fact that remains something of a mystery to science. What's most crucial for today's video, though, is that largely due to its lightweight, low density, and high reactivity, lithium is a key component in almost all portable electronic devices because of its amazing functionality in batteries. Getting the lithium into everything from your phone to game consoles is no mean feat, however. Lithium doesn't occur in its pure form anywhere in nature. Instead, it's found in compound form inside minerals and particularly salt lakes. To get to it then, the lithium has to be isolated, which is a difficult task. And again, it's not as though this stuff is everywhere in any variation. Although it is present on every continent, the amount varies, with some countries known to have far more mining potential than others. The Lithium Triangle is a name given to 3 such countries close together that reportedly have around 75% of the estimated worldwide lithium supply total: Chile, Argentina, and Bolivia. These countries all boast massive salt flats which are packed with lithium, leading more and more lithium-dependent companies to set up there. To extract it, workers must pump water into the ground to force the salt brine that's buried beneath to rise to the surface. That brine is then evaporated in the hot sun, leaving behind various useful products, including lithium. It's a process that can take up to 2 years, though, which means the lithium supply chain is almost always under some sort of time pressure. In Australia, another serious player in the world's lithium market, there have been some alternative hard rock mining techniques put to use to gather it more quickly, but there are downsides, such as concerns about the impact on the environment and on workers' health. You might think that given the difficulties in getting it then, we'd try our best not to use or need lithium too much. But no. Today, lithium is more popular than ever all around the world, with annual consumption reportedly rising by about 9% every year. More and more industries are depending on this one useful but invariably tricky element. Again, it has become vital in the manufacture of portable power batteries, which means it's crucial for everything from smartphones to laptops. The world is more or less hooked on these gadgets nowadays, and many people choose to regularly upgrade their tech. So it's not as though, judging by current behaviors, we're about to wean ourselves off of lithium anytime soon. Unsurprisingly, there are reasons why lithium batteries are favored by tech producers over numerous other options. Lithium products are able to sustain higher voltages and have much higher potential charge storage compared to most non-lithium batteries. They're also generally deemed to be low maintenance and longer lasting. More than just phones and computers then. For these reasons, they're also used in clocks, cameras, and in health and medicine, with modern pacemakers powered by lithium, for example. Perhaps most significantly of all, however, lithium batteries are key for electronic vehicles too, an extremely fast-growing industry in modern times. Altogether, this is the main reason why scientists and indeed manufacturers, engineers, and electronics companies are so worried about lithium shortages. While there are reserves of lithium currently on Earth, the massively rising demand may very soon prove to be too much. The projected timeframes differ from source to source, but increasing numbers are struggling to see how we can comfortably continue at current rates past even 2030. Given that the use of e-vehicles is set to grow and our dependence on portable electronics isn't likely to fall, the turn of the next century, the year 2100, has been widely mentioned as a date by which a collapse of the lithium supply could well have taken hold. At present then, the wider outlook isn't good. Lithium's relatively newfound position as king of batteries means that it's also become an extremely important ingredient in the bid to end use of fossil fuels and improve carbon emission stats. Where some renewables may struggle to maintain steady and reliable power, Lithium batteries have the potential to solve that problem. They excel at keeping energy stored for long periods of time, making them seriously useful in long-term green energy plans. Such is its growing importance, lithium has even been given the nickname of white gold. It's that valuable. But because of all the issues surrounding it, including the cost, time, and potential environmental impact of its extraction, it has become a more and more challenging and controversial struggle to make it work. It is possible to recycle lithium, which would naturally help to alleviate the predicted shortages, but so far, widespread reuse models are few and far between. There are positive signs, but not standard procedures. Finally, there are more reasons than just technology as to why we should want to try and find a workaround here. Although lithium's main draw is undoubtedly in batteries and sustainable energy, scientists can also use it for a surprisingly wide variety of different needs. For example, it's used as a medicine in small amounts and is prescribed in some regions to treat mood disorders, including depression. Why it works is still a little bit of a medical mystery, but lithium can seemingly help to stabilize mood, and it's thought that it may play other roles in maintaining a healthy body as well. Elsewhere, lithium is used in nuclear fusion research. The lithium-6 isotope doubles up as an effective shield against radiation, with widespread applications in the field. And lithium-7 can be used as coolant in nuclear reactors and nuclear fusion tokamaks. In more everyday life, the element also turns up in the manufacture of some ceramics and glass. And it's present in a lot of cookware, thanks again to its lightweight, relative strength, and thermal qualities. In short, the contemporary world really needs it to hang around. Thankfully, right now, lithium reserves are still generally deemed to be steady and not especially in danger. But there are growing fears of an emerging problem that's creeping up on the horizon. As it stands, lithium is set to become much harder to acquire, perhaps within the decade. And that inevitably means that it will become more expensive. And with so much of our current and future technology apparently resting on this stuff, that represents a big concern. In some ways, it's a strange turn of events. Lithium was one of the very first elements to form in the universe after the Big Bang. It's always been here. But human civilization has arguably never needed or even noticed it quite as much as it does right now. After billions of years, it's suddenly become vital to the running of modern human society. And so, unless something changes soon, unless more reserves are found or lithium alternatives are devised, we could be heading for trouble. A key component in our increasingly high-energy lives appears to be under genuine threat. And that's why scientists are so worried about running out of lithium.